Good afternoon, pilot teachers, and good afternoon, students.
Good afternoon, Mr.
Thank you. Sit down. Okay, we'll start off with the correction to the homework. And that correction was to look at definitions. And after we do the correction to the homework, what we are going to do for our lesson today is basically to look at how a caldera is actually formed. And calderas are also associated with volcanicity. We'll start off with the correction of the homework. And that's definitions, and all you have to do is double check with the definitions and make your corrections. The first word given was to look at cinder cone. We'll start with Shelley. Your definition of what cinder cone is. Can you read out loud and clear? And the rest of you, to ensure that your corrections are done.
Volcanoes formed by a buildup of ample tephra of various types.
Okay, volcano which is built up of ample tetra of various type, or in other words, built up of ash and cinder material. Volcanoes which are built up mainly of ash and cinder materials, or we can have also volcanoes which are built up of pyroclastic materials. Okay, we'll double check on the definition from the monitor. It tells us also that it is a small, steep-sided, cone-shaped volcano made of volcanic cinders and other rock particles. The next word, Catherine, shield volcano.
A volcano composed of very basic, non-viscous lava which flows quickly and congeals slowly, producing a very gently sloping cone.
Okay, she's mentioned about a volcano which is not very steep-sided, which is mainly formed mainly by flow of lava. But we can also have in a shield volcano a steep-sided volcano which is made up mainly of lava which is rich in or has a high content of silica. But the main idea or the main point that we should have for a shield volcano is that it is generally a volcano which is actually made up of layers of solidified lava flows. Okay, we check the definition for shield volcanoes. A broad, dome-shaped volcano made of layers of solidified lava. Okay, with that shield volcano definition, we move on to the third word given, Shelley, composite volcano.
A composite volcano is a single cone comprising alternate layers of ash or other pyroclasts and lava.
Okay, very good. We are basically looking at alternate layers of ash and lava. And for ash, we can also include pyroclastic materials. So where you have alternate layers of ash and lava, then the volcano is said to be composite or strato. We move on. The next word given, crater. Susan.
A crater is the name given to a deep hole inside a volcano.
A name given to a deep hole inside a volcano. We check definition, name given to a deep hole inside a volcano. We'll double check on that definition with the information from the monitor. Note, it is supposed to be the funnel-shaped basin surrounding the vent at the summit of a volcano or on its flanks or the side, because sometimes you can have subsidiary conelets of which they might also have a funnel-shaped basin. It is formed by either a major eruption or the collapse of a volcanic cone. So we're looking at the crater. It is supposed to be the funnel-shaped basin at the top of a volcano usually, where magma is allowed to flow out from. Okay, we check on the definition. The next word, Gideon, Magma Chamber.
A magma chamber is the main area where magma is generated for eruption to occur.
Okay, the main area where magma is generated for the eruption to actually occur, and he's correct in saying that, but also note that it is supposed to form under the surface, not out on the surface. It's the general area where magma is generated under the surface, allowing the flow of magma up to the volcano and then out from the crater, resulting in eruptions. Okay, we check on the definition. A simple definition given from the monitor there. Magma chamber, an area where magma is stored or generated underground. Moses, the next word, vent.
A vein is a deep hole which lava is pushed out of the surface of the earth.
A deform?
Deep hole.
A deep hole, okay, a deep hole where actually lava is pushed out from under the surface of the earth. Okay, we'll check on the definition. We'll make corrections also. The definition would be similar to what Moses has given there. The orifice of a volcano, or the vent or the passage of a volcano, consisting of a vertical passage leading down from the surface into the magma chamber. It is the opening through which a volcanic eruption takes place, and it is usually surrounded by a cone. We double check on that. Caleb, the last word, lava, that was given for the definition or for your homework.
The molten material extruded from a volcano by fissures eruption onto the surface of the earth.
Okay, good. We'll check. His definition is very similar to what is on the monitor there. The molten lava is supposed to be the molten material or magma extruded from a volcano or by a quiet eruption onto the surface of the earth where it cools and solidifies. That material, when it is under the surface, it is magma. When magma comes out onto the surface, then it becomes lava. We cannot say magma on the surface. We say lava as soon as magma reaches or comes out onto the surface. Okay, and that concludes those words that you were supposed to look up their definitions to for your homework. Now we will move on to looking at the information on Caldera. And with that information, you will be required to explain and also to do your construction of well-labeled diagrams to show how a caldera is generally formed. Okay, we're looking at the definition now from the chart. From the chart, it tells us that a caldera is a large circular basin-shaped volcanic depression created in one of the three ways. We must make sure that we do not get the definition of a crater confused with the definition of a caldera. The difference between a crater and a caldera is that in a crater, you would usually find that it is a small opening, usually a smaller opening in comparison to a caldera at the top or the flanks of volcanoes. Whereas a caldera is a large circular basin-shaped volcanic depression. And this particular volcanic depression can be created in one of the three ways. And the three ways in which a caldera can be formed are: one, by destruction of the upper part of the volcano, of the volcanic cone, by an eruption of great force. So if we look at, for example, the monitor here and the diagram showing that, once upon a time, the dotted lines represent the cone or the slope or the side of the volcano, and due to a huge eruption, all of this area here has been actually removed or blown off, resulting then in a depressed area being created. That's the first way in which a caldera can be formed. The upper part of the volcanic cone are actually destroyed by great force or by an eruption. An example is the Katmai, which is a caldera in Alaska. That's just one of the examples, and we can look at many other examples of calderas also in Papua New Guinea and around the world. The second way in which a caldera can be formed is by the collapse of the volcanic cone inwards, or the engulfment of the volcanic cone. So this time, we still have the line here showing originally where the sides of the volcano was, and due to the collapse, all of that area was actually engulfed inwards, resulting then in a depression. And that's the second way in which a caldera can be formed. The third way in which a caldera can be formed is by the gradual reduction of an extinct or a dormant volcano by erosion. So given time, if we have an extinct volcano sitting there, erosion can actually remove the sides or the slope, then resulting in a huge depression being created. So those are the three ways in which calderas can actually be formed. We look at a note here. I think I mentioned that at the beginning. Note that the diameter of the caldera should be many times that of the original volcanic vent. So a caldera should be, or it will be larger than a crater or the original volcanic vent. We have on the board here a sample or a diagram of what, sample of the diagram of what you will be required to actually work on. And here we have a volcano before violent eruption. During the eruption, note that the top of the cone has actually been blown off or broken up, so you can see the enlargement now in this area here. Gases and lava bombs actually ejected during the violent eruption, and then given time, a caldera is actually formed. The top of the cone has actually sunk into the magma as a result of that violent eruption. This shows generally the stages in the development of a caldera. We look at the information from the monitor on the evolution of the caldera at Crater Lake, Oregon, United States or USA, that is. Early eruptions from the prehistoric volcano, Mount Mazma. Great eruptions of ash flows emptied the magma chamber so that the top of the volcano collapsed. And the collapse of the summit into the magma chamber formed what is the caldera today. Here we are looking at the blowing off of the top of the volcanic sides. From the monitor we've looked at eruptions, and as well as that the sinking or the engulfment of the materials resulting in a depression. It goes on to say there, the lake formed in the caldera over time, and minor eruptions produced small volcanoes also in that particular lake. So you can see a volcano uprising or coming out, and already the area filled up with water, resulting in the formation of the lake. Your task. You are now going to explain, with the help of well-labeled diagrams, how a caldera is formed. You have three ways in which a caldera can be formed, and you can use, or your diagrams when you are constructing can explain the first way in which it is formed, or you may decide to do a diagram to show the second way in which a caldera is formed, or you may decide to do the third way in which a caldera is formed. You have a choice, and you can select from either 1, 2, or 3, but you must show your information in diagram form, and as well as that, you must label your diagrams and explain your diagrams when you are constructing. at the end, you might have something that would look like what is shown here on the chart. But you'll have to decide which of those three you are going to actually use, and you do your construction according to which one you would have chosen. Okay, I'll give you time now for you to work on that. And make sure that your diagrams, for each of the diagrams you construct, they are well labeled to show the stages in the development of a caldera. Yeah, any questions? Any questions before you start on that? No questions? Okay, you may go ahead now with that activity. Okay, and with those activities then, that will also bring us to the end of our lesson. But before we finish, I'd like to look at what we have covered so far to sum up. And then for anyone who has yet to complete your diagrams, make sure those diagrams are constructed and also labeled. Okay, so what we have looked at today, we've looked at a caldera in association with what we have covered on volcanicity. Definition to a caldera is simply a large secular basin-shaped volcanic depression. And it can be created in one of the three ways. A caldera can be created by destruction of the upper part of a volcanic cone by an eruption force. In other words, the top part of the volcano gets to be blown off, resulting in a depression, giving us a caldera. It can be created by the collapse of a volcanic cone inwards or engulfment. Okay, for this particular information here, note, sometimes you can have the magma chamber with the continuous eruption can be emptied. And when the magma chamber is actually emptied, that leaves a vacuum under the surface where the magma chamber is. So that means the top cone or the top layer then gets to be engulfed, or it collapses in, resulting in a depression, giving us a caldera. You can also have fault lines or weak areas where the fault lines are created, resulting then in the engulfment of the upper cone or the cone at the top. And when that happens, a caldera is created. Finally, a caldera can be formed by gradual reduction of an extinct or a dormant volcano through the process of erosion. Given time, like the example that we've seen of Oregon, given time, a lake might actually fill up that particular depression or the caldera. And if the chamber under that particular caldera is still active, then what might happen, like in the case of the crater lake in Oregon, a volcano, or you might have another volcano or volcanic peak rising. That's if the magma chamber is still active. It can still release, where the caldera is, release the flow of magma up onto the surface and the creation of volcanoes inside the crater lake. And that is also possible. Okay, and with that information, can now stand up, class. And to the pilot teachers, our keyword for lesson 38 is caldera. Good afternoon and thank you, class.